what we need to do. All right, so first thing, I like to start with left hand side. So as you know, our left hand side is approximately equal to, it says cos 3x, cos 3x. All right, this is our left hand side. Now, as we know, cos 3x is equal to, we can rewrite that as the cos of 2x plus x. This is cos 3x, the cos of 2x plus x. But then we know what is the compound angle formula for this. Cos 2x plus x is given by, this is given by cos 2x cos x. This is given by cos 2x cos x minus sine 2x sine x. Minus sine 2x sine x. Aha. But then now, we realize that we reach where we need to use the double angle formulae. The double angle formulae for cos 2x, there are three of them. You know, you have 2 cos square x minus 1. You have 1 minus 2 sine square x. And you have cos square x minus sine square x. Which one will you use is up to you. I will use 2 cos square x minus 1. Why? Because I'm multiplying it by cos and I want everything to be in terms of cos. So I'm going to write 2 cos square x, 2 cos square x minus 1. That is a double angle formula for cos 2x. And it is being multiplied by cos x. All right, nice and easy. It's being multiplied by cos x. Minus sine 2x as we know it. Sine 2x is 2 sine x cos x. So we have 2 sine x cosine x, 2 sine x cos x, and that is being multiplied by sine x. Nice and easy. This is being multiplied by sine x. And so what we do now is we expand out these now. Expanding through, we're going to get 2 cos square x times cos x. That's going to give us 2 cos cube x. This is 2 cos cube x minus cos x times 1 is cos x. All right, cos x times 1 is cos x. Then minus, now 2 sine x cos x times sine x becomes sine square, because sine times sine is sine square. So it becomes 2 sine square x, 2 sine square x times the cosine of x. Now here's where the trouble comes in now, because we have everything in terms of cos, but then we have this sine square right here. But sine square is 1 minus cos square. So let's go ahead and write that. Sine square is 1 minus cos square. So this is going to become 2 cos cube. This becomes 2 cos cube x minus cos x. And then we replace the sine square here with 1 minus cos square. So it becomes 2 times 1 minus cos square x. 1 minus cos square x. And it's still being multiplied by, of course, cos x. So all we need to do now is expand over here. So we need to expand it, and when we expand it, what we're going to get is 2 cos cube x, 2 cos cube x minus cos x, 2 cos cube x minus cos x. And when we expanding this now, we have minus 2 times 1 is minus 2. But then it is minus 2 times cos x, which is minus 2 cos x. Remember, we're multiplying. We multiply the minus 2 times the 1, and then we multiply the minus 2 times the cos x to get minus 2 cos x. Then the minus 2 times the minus cos square is plus 2 cos square, and then plus 2 cos square times cos x becomes plus 2 cos cube, plus 2 cos cube x. All right, nice and easy. And so now we have 2 cos cube x plus a 2 cos cube x. When we add those two together, what we're getting is 4 cos cube x. This becomes 4 cos cube x. 4 cos cube x. And then what we have now is minus cos x minus 2 cos x. Those two together becomes minus 3 cos x. Is that what we have? I'm sure that is what they want us to prove. Yes, that is what they want to prove. And that is equivalent to our right-hand side. Nice and easy, soft. That's equivalent to your right-hand side. So you can just write down easily brushed aside. Easily brushed aside. Right. Nice. So good with this question. No issues whatsoever. Let's look at part 2 now. Part 2 now we have that hence or otherwise solve cos 6x minus cos 2x. So we need to solve cos 6x, solving cos 6x minus cos 2x. Solving cos 6x minus cos 2x, and we're solving that equal to 0. Solving cos 6x minus cos 2x equal to 0. All right. And it says hence. Hence means we're going to utilize the knowledge that we have from above. Now, since it says hence, the only thing I can see is that I can separate cos 6x. Well, I'm not even going to use the hence. We can use hence, but I'm going to go with otherwise because I know that this is the difference of 2 cos. You could go with hence by separating this as cos 4x plus 2x, and then you know that cos 4x from around here is 4 cos cube x minus 3 cos x. But I don't want to go that route. That seems more tedious. I'm going to go this route. The route I want to go is this route. The route I want to go is this route where I'm going to use that the difference of 2 cos is given by minus twice the sine. So it's minus twice the sine of half the sum. So it's minus sine of half the sum, which is 6x plus 2x divided by 2 times the sine of half the difference, which is times the sine of half the difference. Half the difference is 6x minus 2x over 2. And that is, of course, equal to 0. Nice and easy. So now what we're getting then is, if we divide through by minus 2, we're going to get that the sine of 6x plus 2x is 8x. 8x over 2 is 4x. That becomes the sine of 4x. Then the sine of, now 6x minus 2x is 4x. 4x over 2 is 2x. This becomes sine 4x times sine 2x. Of course, you had the times the minus 2, and this is equal to 0. So if this is equal to 0, the only way this can be equal to 0, it can't be the minus 2 fault make it be 0. So it must be that sine 4x equals 0 or sine 2x equals 0. So all we have to do now is write that down. So it's either sine 4x is equal to 0. So it's either sine, why is it still in caps? Sine 4x is equal to 0 or sine 2x is equal to 0. That's what we have. It's one of those two. Now, if it is sine 4x equal to 0, then this is, you can draw a circle. Draw a circle for me. All right, and split up your quadrants. Split up your quadrants. All right, if sine 4x is equal to 0, 0 is in the first quadrant, so your principal acute angle is going to be sine inverse of 0, which is 0. Sine inverse of 0 is 0. All right. Always remember that sine inverse of 0 is 0. All right. But then remember, sine is positive in the first quadrant and sine is positive in the second quadrant. So what you're getting then is 4x is equal to 0, or 4x is equal to pi minus 0, which is pi. But remember now, you know that since it is 4x, you want your answer to be between 0 and 2 pi. So you can spin around the circle one more time to get that. If you go around the circle one more time, you're going to get 2 pi plus 0, which is 2 pi. You have to go around the circle one more time. All right, and you go around the circle one more time to get the 2 pi plus pi is 3 pi. So you're going to get 3 pi. All right, now let's see. Since it has 4x here, I think we can spin around the circle 4 times. So let's go around the circle another time. This is going to be the third time. Going around the circle again, you have 2 pi plus pi. 2 pi plus pi is 4 pi. So 4 pi can be a part of the solution. And then this 3 pi plus 2 pi is 5 pi. So go around the circle 3 times so far. Let's go around the circle 4 times now. Going around the circle the 4th time, all right, we're going to get this 4 pi plus 2 pi is 6 pi. All right, that's 6 pi. And then this 5 pi plus 2 pi is 7 pi. All right, and let's go around the circle one last time, a 5th time. Going around the circle one last time, what we're going to get is 6 pi plus 2 pi is 8 pi. And 7 pi plus pi is 9 pi. So these are all the possible values for 4x. Now we're going to divide through by 4. So dividing through by 4, that implies that x is equal to 0 over 4, comma, pi over 4, 2 pi over 4 is going to be pi by 2. So we can write that pi by 2. Then 3 pi over 4 is going to be 3 pi by 4. Then 4 pi by 4 is going to be pi. That's going to be pi. Then 5 pi over 4, that's going to be 5 pi by 4. Then we're going to have 6 pi over 4, which is 6 pi by 4. And 6 pi by 4, yeah, let me just write it as 6 pi by 4. Can simplify it a little bit more, but write it as 3 pi by 2. Then you're going to have 7 pi by 4. All right. And then after you have 7 pi by 4, you're going to have 8 pi by 4, which is 2 pi. But we can stop right here. We can stop right here. Why can we stop right here? Because 9 pi by 4 is going to be bigger than 2 pi. So this one is not valid. So this one is not valid. That one, not valid. All right. So those are all the values of x we get from this solution. Let's solve sine 2x equals 0 now and look at the solutions we're getting. So for the next part, we're solving sine 2x is equal to 0. Solving sine 2x equal to 0. Again, the two possible answers that we're going to get is 2x is equal to 0 or 2x is equal to pi. All right. Now we can go around the circle one more time. By going around the circle one more time, we're going to get 2x is equal to, going around the circle one more time, we get 0 plus 2 pi, which is 2 pi. All right, we can go around the circle one more time to get 4 pi, and then we stop there. And from over here now, we can go around the circle one more time to get that 2x is equal to, go around the circle one more time, you have pi. The next thing you're going to have is 3 pi. So you divide through by 2 now. Divide through by 2, and so from this part of the solution, we're getting x is equal to 0, or 2 pi over 2 is pi, or 4 pi over 2 is 2 pi. And from this side, you're getting that x is equal to divide by 2, you get pi by 2. And divide by 2, you get 3 pi by 4. Now, all of these answers that we get right here, these are already in the solutions up here. And so this is the final answer up here. All of these are the final answers. All right, all of these is the final answer. All right, so that's the answer. 0, pi by 4, pi by 2, 3 pi by 4, pi, 5 pi by 4, all of that stuff. That's that. Nice and easy, soft. Now let's go to the next part of the question. The next part of the question, part B. Part B, it is saying that we need to express f of 2 theta in the form 3 sine 2 theta plus 4 cos 2 theta. That's this is f of 2 theta. So f of 2 theta is equal to, f of 2 theta is equal to 3 sine 2 theta, 3 sine 2 theta plus 4 cos 2 theta. We need to express it in the r sine form. So in order to express it in the r sine form, the first thing we have to remember is that r is equal to the square root of a squared plus b squared. So r is going to be equal to the square root of 3 squared plus 4 squared, square rooted. All right, so when you work that out, you're going to get 5. That is r. And the next thing we need to find is alpha. Alpha is going to be tan inverse of b over a. That's alpha. Alpha is tan inverse b over a, which is tan inverse of 4 over 3. Tan inverse of 4 over 3, we can work that out. So we get in tan inverse of 4 over 3. Tan inverse of 4 over 3 is 0.927. That's tan inverse 4 over 3, 0.927. All right, that's tan inverse of 4 over 3. All right, nice. Alpha, tan inverse 4 over 3, good. So now we can finally put it in the correct form. F of 2 theta, and so f of 2 theta is equal to 5 sine, so it's 5 sine 2 theta plus alpha, so it's 5 sine 2 theta plus 0.927. All right, that's f of 2 theta. Nice and easy, soft. That's f of 2 theta. They're giving away 6 marks to do this. I don't know why, but they gave us 6 marks and we have it done and dusted. All right, nice and easy. The next part says hence or otherwise, find the maximum and minimum values of 1 or 1 minus 7 f of theta. Now, first thing we can start with is that f of theta will be bounded between, and I think that should have been f of 2 theta. F of theta will be bounded between r and minus r. R is 5, so f of theta is bounded between 5 and minus 5. Then what we can do next is divide through by minus to get that minus f of theta. Anytime you do division by minus 1, you change the sign. All right, so it becomes minus 5 by minus 1 is 5, and then 5 divided by minus 1 is minus 5. So this is minus f of theta. Then we add 7 to both sides to say that 7 minus f of theta 7 minus f of theta will be bounded between b less than or equal to, add 7 to both sides. 7 plus 5 is 12. 7 plus minus 5 is 2. All right. And then we now reciprocate it. When you reciprocate it, the signs will change again. So the signs will change again. This part becomes 1 over 2. We reciprocate this to get 1 over 7 minus f of theta. And then we reciprocate the other one now. And so we're going to get 1 over 12. That's 1 over 12. Nice. All right. And so what can we conclude? We can conclude that the maximum is going to be a half and the minimum is 1 over 12. And so hence the maximum will be 1 over 2 and the minimum will be 1 upon 12. All right, nice and easy, soft. That's what we have. That's the max and that's the min. And that takes care of question 3. Very easy, soft. Now we can go to question 4. Question 4 says the circles C1 and C2 are defined by the parametric equation as follows. C1 is x equal to root 10 cos theta minus 3, y is root 10 sin theta plus 2. And C2 is another parametric equation. And from C1 and C2, it said determine the Cartesian equation of both of them.